All right. Hey, everyone. Sorry that I forgot to screen share today during class. It's been a minute since I did that. So I'm going to very briefly go through everything that we covered today without the pauses waiting for everyone's computers to behave. So the first thing that I'm going to do is remind you where to find everything related to SPSS on Blackboard. So you go to our page and then you click on SPSS, and then you will see the assessment sample data that we're going to use in just a minute here. You will see how do you use SPSS instructions. This is what I handed out in class. You will see a PowerPoint about SPSS. And then if you would like to try to download SPSS onto your home computer or your laptop, you can open this tab and you can download it here. Okay, and that's through Virginia Wesleyan. We have a license such that you can use it at home. So what we're going to do is download this data set. I am saving it here. If you already have SPSS installed on your computer, all you have to do once it's downloaded is open it, and it will open SPSS. So it's going to open on another screen of mine. So I'll pull it over to the screen I'm sharing once it opens. If you get a message about it running in Unicode mode, just hit yes, it's fine. All right, so I'm pulling this over. Here we go. Okay. So briefly walk through SPSS. There are two windows that you'll usually see popping up that when you're working with SPSS. One is the actual data, which is more like an Excel spreadsheet. And one is the output. So this is where all the analyses you do will pop up as you do them. So what I am going to do is bring the data set itself forward and walk you through just a couple features. And then we'll go and work through the questions that we went through in class, the directions. So this part of SPSS will look pretty familiar if you've ever tried to enter data into like Google Sheets or Excel or anything like that. The main difference with SPSS is that up here at the top, your variables, essentially like your top row, your header row, are locked. They're already there. They're established. You don't need to worry about them. And that's because they are here. So when you create an SPSS data set, you spend some time putting this together. So these are all the names of our variables. Some of them might have a label as well. SPSS allows you to indicate what the different values mean. So for example, for year in school, you can see we had different numbers that meant first year, sophomore, junior, senior, fifth year, other, or if someone just happened to not be a student. And then for each questionnaire, like the questionnaires you all have been answering in class, you answer them with a Likert scale typically, you know, like a 1 to 5, 1 to 7, something like that. And you can tell SPSS these are what the numbers mean for that as well. So quick orientation to these variables. Some of these are pretty self-explanatory. We've got year in school, we've got race, we've got a gender, age, and then here are some of so this is based off my research, so that's all appearance related stuff. So we have the physical appearance comparison scale, which is about, you know, the negative effects you might feel from comparing yourself to someone else, essentially. We have the body appreciation scale, which is about positive body image, appreciating your body, liking your body. We have the body checking questionnaire, which is engaging in behaviors like checking to see if your thighs touch when you sit down, or walking by a reflective surface and sort of checking everything about your body out. And then we have the CESD, which is a measure of depression. So that's often used. So in this case, this measure is our measure for discriminate validity, just like y'all are including. So I'm going to go ahead and put this side by side right now with the instruction sheet. And then hopefully you'll be able to follow along as I go ahead and walk you through these. So SPSS will do everything that we've done in class so far by hand, like that. Okay, so it's really, really rapid. So let's start with just like looking at some of our descriptives, the ways that we can describe our variables. So let's think about frequencies. So a lot of what we'll do in SPSS will come from this Analyze menu at the top. So you go to Analyze. In this case, we're going to Descriptive Statistics, okay? And then we're going to look at frequencies first, okay? When you do that, you'll get this little pop-up window. And that will give you all the variables in your data set to look at. So in this particular case, let's look at frequency for age. A couple ways you can get it over into the working area here. You can click on age and then click on the arrow and it goes over. Or you can double click on age and it'll just go over. The way you tell stuff to run in SPSS is you just hit OK. And when you do that, you'll see our output window comes up. And it has our breakdown. This data set was a college-based data set. So you can see the vast majority of the people, really 96.8% of the people, right, were age of 22 or younger. We had some non-traditional folks as well. But so this tells you how many people you had that were each age, what percentage of your sample were that age as well. Okay, so nice, interesting data, but maybe for age, that isn't the most helpful information, right? Maybe instead we need like measures of central tendency, mean perhaps. Okay, so then we're going to go to Analyze, go back to Descriptive Statistics, but this time we're going to go to Descriptives. You'll get this little window that pops up. Again, let's go ahead and put age over. I double click that time, but you can click then arrow as well. And we just hit OK. And then what we'll see is this gives us our average age, which in this case, our mean age was 19.9, the standard deviation for age, the youngest person we have in the data set, and the oldest person we have in the data set. Okay. All righty. So before you do anything with your data, once you get it after you collect your surveys from 30 people, you are going to have to do a couple things. And one is summing up the totals. But before you even do that, you need to check and see if any of the scales, particularly any of your published scales, include any items that are reverse coded. And so what that means is essentially the question is asked in the opposite direction to try to disguise what the questionnaire is really trying to get at. And so then we have to tell SPSS to help us put it all in the same direction so that we can run analyses and have everything be accurate. So the example that I'm giving is that physical appearance comparison scale, that PACS. There's one item that's recoded on the PACS. So we're going to go ahead and learn how to do that. So you go to transform. And then what we're doing right now is called a recode. You'll notice there's one to do it into same variables. Don't do this. Every stats professor I've ever had has told me don't do this, because what happens is this overwrites your original data. So if you mess something up, you like can't go back and fix it. So always, always, always recode into different variables. SPSS has no cap on variables, so there's no disadvantage to doing it this way. All righty. So now what we're going to do is we're going to find the variable we need to recode. So I would have looked at this beforehand, seen which variable do I need to recode, and is it more than one item on the scale? For the PACS, I know there's just one reverse coded item, and that's the fourth item. So in my data set, I've called it PACS 4. Okay, so now we're going to tell SPSS we want you to create this new variable. We're going to give it a name. We're going to call it the PAX 4R. Okay, and we hit change. And so that's telling SPSS, take the information from PAX 4 and put it in this new variable we're creating. Then you click old and new values. And here is where we tell SPSS how we want them to transform the variables. And so we have a scale on the PAX from 1 to 5. Again, that's something I would want to look at before I went and did this recode, right? Is it 1 to 7? Is it 0 to 4? I know the PAX is 1 to 5 just because I use it a lot in my research. So what we say is if someone scored a 1, now make that a 5. And then we click add. We say if they scored a 2, now make that a 4. Here's where we have to be smarter than SPSS. SPSS is only as smart as what we tell it. So we do have to tell it if someone scored a 3, keep it a 3. And then we also have to give it the other way. So if someone scored a 4, it's now a 2. And if someone scored a 5, it's now a 1. Okay. So you're telling SPSS, reverse all these values for me. So you click continue. And then you click OK. And it looks like nothing happened. But if I go back to my data view here, to my variable view rather, you'll see that, oh, now there is a variable called PAX4R that I created. And if I go to data view and I go all the way over, we see not only is there something called PAX4R, but there are values in it. So SPSS recoded data from 220 people for us that fast. So again, this is why I say SPSS is your friend, because it can do all this so much more quickly than we could do it. All right, so then once you've done all your recodes, then what you want to do is actually add up your scale. Otherwise, so like the PAX has 5 items, you know, some other scales have 10, some scales have like 30, right? You would have to like try to correlate all those individual items, and that's not the question we're trying to answer, right? We're trying to answer, how are these scales related to the scale you're creating, to the questionnaire you're creating? And so the way we do that is we create basically a full scale version, a variable that accounts for all of the data. Now, sometimes these will be a straight sum of the data, and sometimes these will be like an average, like you add up the number of items divided by the number of people. So for your individual questionnaires, you can decide what you prefer. Your variability will be the same. Your results will be the same regardless of what you do. It's just sort of which one you prefer. But you do need to make sure as you look at the published questionnaires you're using that you pay attention to how those are supposed to be added up. Are they averages? Are they sums, etc.? Okay, so the PAX is just a straight sum. So we're going to go ahead and do that. So we're going to transform again, and we're going to compute variable. Alrighty. And so now we're going to tell it, we want you to make a variable called PAX total. Okay. Now here again, there's a couple of really interesting things we can do. So the most common way is to go back to our arrowing technique. Tell it, okay, we want the PAX 1. If you trust yourself not to make typos, you can actually type up the variable names with addition or whatever transformation you need to make right here. I don't necessarily trust myself to do that. So we're going to just arrow over. Okay, so we got PAX 1 plus PAX 2 plus PAX 3. Now here it'd be really easy to just say, oh, and then we put in PAX 4. But we recoded for a reason. So we're going to go down to the bottom. We're going to get that recode, because if we put in the non-recoded one, it won't show an accurate representation of the overall score. Okay. Now with the PAX4R like that, they're all in the correct direction. And then we got the PAX 5. That's it. It's 5, things, 5 items. Boom. We hit OK. And again, it looks like, did anything even happen? Yeah. So we go here. We now have another new column, a new variable And it has calculated the sum, again, for all 220 people in this data set for those 5 items on the packs. Pretty awesome. All righty. So once you get through all of that, once you get through doing your recodes, adding things up, your analyses for your group project are actually not that difficult. So one of the things you're going to do for your new scale is do a reliability analysis or look at internal consistency. We're going to do that using alpha, which is the most commonly used one. It's the one that the symbol looks like the Jesus fish, okay? And so we're going to go analyze again. And we're going to go, I don't know, about 2/3 of the way down here, I think, to where it says scale, because we're looking at a scale. That's what you guys are creating, a scale or a questionnaire. And then we're going to say reliability analysis. Okay. And so now what we're going to do is we're going to put in all the items on that scale. So for the packs, we're doing packs 1, packs 2, packs 3. Oh, again, we want to go packs 4, but in fact, we need to go packs 4R, right? Make sure that we are doing that correctly. Otherwise, our internal consistency will be really poor. So if you've made recodes, those have to go into your reliability analysis. And then packs 5. Okay. And then we are going to tell it we want some extra information. So if you click on statistics, you'll get this pop up. And we will tell it we want descriptive information for each item for the scale as a whole. And then we also want it if an item was removed from the scale, especially since you're creating new scales. It's entirely possible you'll have an item or two that just don't really hang with the rest of the scale well. So by using this metric, we essentially, it'll tell us statistically whether the scale would actually be better if we took those items out. Let's also get the inter-item correlations. And then let's get the summaries for the means, the variances, and the correlations. Okay. So checking these 3, checking correlations, checking everything but covariances in this box. Hit continue. Hit OK. And now it gives us the alpha, that internal consistency. Now, one of the other reasons, besides it being short, that I use the packs for this is to show you that sometimes you're not going to get great reliability, and that's okay. I'm not going to ever dock you on this project for you having not great reliability because it's a new scale. You might not. The packs is published and used in research, and it still has only what's called like the acceptable level of reliability. So, you know, that's all right if yours is not at that 0.9 level that we want for clinical stuff, right? You guys aren't necessarily making that. So going through the other stuff it gives you, you have the mean score on each individual item for the whole sample. And then it shows you how much these items are correlated with each other. What we're seeing is, you know, maybe this PAX 4R, the one that we recoded, isn't the best item because it's kind of correlating at low levels with the other things. And, you know, it's in the right direction because these correlations aren't negative. So we did the recode correctly, but still something we should consider. We could see the summary statistics for the items. And then these are the ones that'll be really helpful looking at your novel scales you're making. Is this will be the scale mean if that item was deleted, the variance in the scale, the corrected item total correlation if that item was deleted. And then here's what you really want to look at. Would the Cronbach's alpha change for the better if we got rid of an item? And in fact, that PAX 4R that we were like, that correlation isn't looking great. The internal consistency, that alpha would go up to 0.82, which is in the good range rather than the acceptable range, if we got rid of that item, right? So maybe the creators of the PACS should ponder that. I actually think there's a revised version of the PACS that does do that now. But things like this can be helpful to look at revisions for scales. Alrighty, so the next thing you're gonna do, that's one of your hypotheses, right? Check, you've looked at reliability. Next thing you'll do is look at validity. So again, for your group project, you have the scale you created, a published scale that you think kind of measures the same thing for convergent validity, and then you have a published scale that measures something differently for divergent validity. And as you'll see on here, we have convergent evidence for construct validity and divergent evidence for construct validity, okay? Mean the same thing. These are just gonna do with simple correlations. So we're gonna go to analyze, correlate, and the one we're gonna use is bivariate. This is the most commonly used type of correlation. Alrighty, so we are going to look at that PACS scale. Let's keep looking at the same thing. Let's go down to that PACS total you created. And then because this has to do with appearance-focused comparisons, maybe we hypothesize that this will be related to that body appreciation, that positive body image, right? So let's put in that body appreciation scale. And this is just FS here means full scale. It's the scale added up. Okay, that's all we need to do is put in the two variables we want to correlate and then click OK. What we see here is we have a correlation of negative 0.400. And we have a couple ways of telling that this is statistically significant. One is the sig, the significance. This is our p-value. Okay, and this says it is less than 0.001. So less than a 0.1% chance this happened on accident. Okay, the other fun thing SPSS does if it's significant is puts these little stars next to the actual correlation coefficient. Okay, so the Pearson correlation, that's your correlation coefficient. That tells you the magnitude of how they're related. And then the sig is your p-value. So in this case, we do have a significant correlation, but it's an inverse correlation, and that's okay. Because what happened here is that higher scores on the PACS mean you're engaging in more of these appearance comparisons, which is actually going to probably make you feel worse about your body. Higher scores on the body appreciation scale say you feel good about your body, right? So it makes sense that they would then be negatively correlated instead of positively. But because it's significant, this is evidence for convergent validity. Very cool. All right, let's go ahead and look at discriminate validity. So again, we're going to go to analyze, correlate, bivariate. Let's go ahead and get rid of the body appreciation scale. And for discriminate validity, I'm using that scale of depression, the Center for Epidemiological Studies depression scale, just because, if we're talking specifically about appearance, there should be a little bit of divergence here, right? So again, that's all you need to do, hit OK. And this tells us the correlation between the CESD and the PACS. So here you can see it is still significantly related. And maybe that's not surprising if we think about the MMPI, right? And how they did pull out that demoralization scale, right? So like if you're feeling bad about your body, you're probably just feeling bad in general, which might relate to depression. Okay. But one thing we can say, and in fact, we can look right above it at our body appreciation one, right? The magnitude of this correlation, the absolute value of it is smaller than that of the relation with the body appreciation scale. So this tells us that there is some evidence for discriminant validity here, that, yeah, it's still significantly related and it's at the 0.001 level. And again, we get some nice stars next to it for that. But it's a smaller correlation. So I would argue that this is still evidence for discriminant validity. All right, if you have questions about any of this, want to meet with me one-on-one, please feel free to reach out to me, contact me, and we will have plenty of time for me to actually help you and when you enter and analyze your data as groups during our group work days. Alrighty, take care, everybody. Bye-bye.